module, we're going to focus on authorization and access control with the auth2 protocol. I'll again start with some conceptual coverage of the protocol without getting too much in the weeds, and then we'll spend most of the module working through the demos, showing you how to leverage the capabilities of auth2 in your apps. First, I'll cover a few more details of the auth2 protocol itself. You'll see that there is a lot of overlap with the OpenID Connect protocol details that I covered in a previous module, which is not surprising since OpenID Connect is a derivative spec from auth2, which preceded it. Then I'll step through showing you how to start using auth2 access tokens to authorize calls to your backend, which also enables those services to filter data or restrict access to certain APIs or functionality based on the identity of the caller. Although this course is mostly focused on what you need to do in your front-end Angular app, we can't talk about authorization and access control without getting into some specifics about whatever back-end technology you are using for your APIs. So I'll be showing how to authorize calls, filter data, and enforce access control in the ASP.NET Core APIs that I'm using for the backend for this course's sample application. But don't worry if you're going to be using something else on the backend. The concepts and general approach are very similar regardless of what API stack you are using. Just the specific framework mechanisms and syntax will vary a bit. Like OpenID Connect, there are some terms you should be familiar with when focusing on auth2. What I'm going to cover here are referred to as roles in the auth2 protocol documentation. But don't confuse that with the concept of role-based access control. That is a different thing. The first term to be aware of is the resource owner. In the context of an Angular application, this represents the end user, someone who has access or ownership to the rights to access some back-end resource. The next term is a resource server. This is the thing that is being protected by the OAuth-based access control and can represent a website, a set of APIs, or even a remotely accessible data store. Next is the client or client application. Like I discussed for OpenID Connect, this is the piece of software that will be making the calls to a resource server. So in the context of an Angular app, it is generally the Angular app itself. But it could also be a backend component that's going to make calls to a downstream resource. Lastly, there is the authorization server. And as talked about earlier in the course, this is pretty much synonymous with STS or identity provider. It is the server application that manages the login and issuing of access control tokens. Similar to the flows I covered for OpenID Connect, auth2 has a set of grant types, which really represent a flow of how a user and a client application obtain an access token to use for authorization. Like with OpenID Connect, there is only one that really matters to an Angular app, and that is the authorization code grant type, which represents the same authorization code flow with Pixie I covered for OpenID Connect. So that's the one we'll be using when I get into the demos. There are 3 other grant types to be aware of if you work on other projects with other client and backend technologies. The first is the implicit grant type, which aligns with the implicit flow of OpenID Connect. Like I discussed in the previous modules, the implicit grant type is effectively deprecated now that authorization code flow with Pixie is recommended for client JavaScript apps, mobile apps, and native client apps. Another grant type is the resource owner password credential grant type. This grant type is designed for applications that have a highly trusted relationship with the STS, in particular a desktop or mobile app that can use the operating system mechanisms to authenticate the user and obtain the access token instead of the client application managing the flow itself. The last is the client credential grant type, and this is one designed for service-to-service communication where there is no end user in the loop. So for example, a backend app could be triggered by a timer or incoming data from an event source, and then needs to call another service to process that event. The authentication and authorization for this kind of scenario would use a client credential grant type. There are two main token types that are part of auth2, access tokens and refresh tokens. Access tokens are the primary type, and we have already had a brief look at them earlier in the course. An access token is, again, typically a JOT, but could just be an opaque string that represents an authorization session. I'm going to focus on JOTs for access tokens, since they encode important information about the user and the session in them that can be used to manage the secured communications with your backend APIs. An auth2 JOT access token will contain encoded data that includes a client ID representing the client application identity with the STS, a subject identifier that is an ID for the end user at the STS, an issuer, which is information about which identity provider issued the access token, when the token was issued, when it expires, the audience, which again represents the API resources that the token allows access to, the scopes, which are access control identifiers that can represent more fine-grained permissions at the API resource. Finally, access tokens can contain an arbitrary number of additional claims that are up to the STS to define and populate. Even though all of this information is encoded into the auth2 access tokens, this information is not intended for consumption on the client side because, again, this is an unsecured environment. So the information in a JOT access token is really meant to be consumed by the resource server the token corresponds to. It is the resource server's responsibility to decode the token, validate the signature and the expiration, and then make authorization and access control decisions about the caller based on the information in the token. As I'll show towards the end of the course, if you want to have access to any of this information directly in your Angular client, you would need to implement an API that the client can call to retrieve the information from the backend after it's been decoded and validated by the API. The other kind of token that is part of the auth2 protocol is a refresh token. Refresh tokens should not be used with Angular apps because they are a long lifetime token that can be used to issue other access tokens. And if you expose those refresh tokens by returning them to the client side in a browser-based app, that token can be hijacked from the debugger tools and used for long periods of time to issue tokens to clients who were never authorized by the STS. There is an ability to silently renew an access token in an Angular app that I will cover later in the course, but it does not involve using the refresh token part of the auth2 specification. So for the purposes of this course, you can ignore refresh tokens and how to use them in auth2. Another important aspect of the auth2 protocol is consent. This is mostly important when the identity provider an application uses is external or not developed and controlled by the same organization that is developing the client and API that will rely on that STS for authentication and authorization. This could be when you allow users to log in with well-known IDPs like Microsoft, Google, or Facebook. Or it could be that your organization controls the STS, but it will be used by partner companies as a single sign-on to a shared set of client applications and APIs. The consent part of the auth2 protocol involves presenting end users with a consent screen after they have been authenticated, which informs the users of what scopes or permissions the client application is requesting on the user's behalf. Those scopes again represent the secured resources that the user and client application will be authorized to access by the STS. and those scopes end up in the ID and access tokens that the STS produces. In the last module, you saw consent screens in the context of auth0 as your STS. Also, if you've ever logged into a site with your Facebook or Google account, perhaps, you probably experienced a consent screen that tells you something like, this app wants to be able to access your public profile or post to your timeline. If your STS is just for your organization or company, and the apps that you build for that company, you may not need consent screens at all. All decent STS options make this a configuration setting that you can choose to show consent screens to your users during the login process or not. In the demos I show in the course with Identity Server, I will not be requiring consent. So now that we've talked about the concepts around authorization, let's get back to coding and leveraging auth2 access control in our sample application. At this point, I'm starting with the sample application as I left it at the end of the authentication modules. The user can log in, get ID and access tokens from the STS, and log out. But I've switched the client application back to using my local machine identity server as the STS instead of auth0. In order to show how the access token is used on the back end, I will be showing how to enable authorization and leverage the information that gets passed in the access token in my ASP.NET Core APIs. I'll show first how to require authentication on your APIs so that an access token is required. Then I'll also show you how you can use the identity information about the user that flows into the code from the access token to do things like filter what data you return for that user and to block access to operations that the user is not authorized for. If we go to the app as it stands right now, you can see in my constants file I have switched the authority URL and client ID back to use my local identity server instead of auth0. In my auth service, I've commented out the metadata that I had to add to override settings for auth0 as well. So I am back configured to run everything local. Now at this point, my APIs are not enforcing any kind of access control. To show that, I could simply go to one of the APIs that handles GET requests and issue the request through the browser. Here you can see the API can still be called and will return the data regardless of who the caller is. That is obviously insufficient for most business scenarios. So we need to first have the backend require authentication and authorization, and then modify the client to provide the access token when it makes the API calls. The first step to adding authentication into an ASP.NET Core API application is to go to the startup.cs file for the API project. In there, I go to the configure services method, and I'll add a call to add authentication, passing bearer as the type and a callback lambda expression to set the options to include the authority URL for the STS, the audience as the project's API resource identifier, and for local debugging purposes, I'll also not require HTTPS by setting the require HTTPS metadata property to false. Next, I need to go down to the configure method and just add a call to use authentication. That gets the API host application set so it can authenticate and use my STS as the authority. Next, I need to indicate which things I want to require authentication for. I can do that for the whole host, all endpoints on a single controller, or just individual endpoint methods on a controller. I'll start by just requiring authentication on my project's API controller. To do that, I go into the controller and simply add an authorized attribute to the class. This indicates to the runtime that I want authorized access to any of the controller actions or methods in that class. When you use the attribute on its own like this, you are simply indicating that it needs to be an authenticated user for the app. But we are not enforcing any specific access control permissions beyond that yet. With that in place, I can run the API project, go back to the browser, and try to load the projects again. And now you can see I get an error in the browser with a status code of 401. If I look at the request in Fiddler, you can see it also returned a header of www-authenticate:bearer, which tells the caller what the API's expectation is of how to get authorized. Specifically, that it is expecting a bearer token to be presented in the call. A bearer token is just a generalized term for an authorization token that could be satisfied with a number of different security protocols, including auth2. So the API rejects the call with a 401 status code, which basically means, I'm sorry, but authentication is required with a bearer token in order to be authorized to call that API. If I wanted to make my whole site secure by default, which is a good thing, I can add a global authentication filter to the host. To do that, I expand the call to add MVC here. In the callback Lambda expression, I will create an authorization policy that requires users to be authenticated, and then add that to the filters for the host. I'll use the control dot shortcut in Visual Studio to resolve the references needed for authorization policy and authorize filter, which just adds the using statements to the top. Now, if I go remove the authorize attribute on the project's controller and save and run, go back to the browser and refresh, you can see I'm still getting a 401 unauthorized response, as I should. And I would now get that on every endpoint in this host if a valid bearer token is not passed in the call to the API. If I am set up to be secure by default like this, I might still need some endpoints that do not require authentication. For those, you can just go add an allow anonymous attribute like this. If I run with that, go back to the browser and refresh, now you can see I'm getting the data unauthenticated again. I'll remove that because I do want all of my APIs authenticated in this case. Now, with the APIs secured, if I go run the client application and try to go to the My Projects listing, nothing happens. And I can look in the browser debugger and see it too is getting the 401 unauthorized response. Next up, let's make the changes needed in the client to start passing access tokens in API calls, so that those calls can successfully authenticate and be authorized. To fix the 401 error code we are getting, we just need to pass our access token to the API following the auth2 spec, which specifies that you should pass that token in an authorization header with a prefix of bearer. In Angular, there are several ways we could go about doing this. Let's start with the simplest way to understand, specifically manually adding the header to the outgoing HTTP request when you make it through the HTTP client. Before I do that though, I need to add a method to my auth service to allow me to get the access token if the user is logged in. I could use the user object that is in the service user property, but that one is not populated until the user explicitly logs in or an isLoggedIn check occurs. I'll add a more direct way to get the access token, if there is one, to make things a little simpler. I'll add a method named getAccessToken. In that method, I will call getUser on the user manager, which again returns a promise that produces a user object. I'll add a promise handler, and in there I will check if the user is not null and the expired property on the user is false. If so, I can return the access token property of the user. Otherwise, I will just return null. And then I need to return the promise result of the getUser call to pass the resulting promise that produces an access token to the caller. Now I want to pass that access token when my client code is making calls to the project's API. To do that manually, I can go into the project service here and go to the getProjects method where it's calling the API for the My Projects list. That comes out of the same module as the HTTP client. So I'll add that to my import statement up here. Next, I'll need to have the value for my access token available in the getProjects method where the request is being sent. So I'll add the auth service to the constructor so an instance gets injected for us. Then, in the getProjects method, I'll call the getAccessToken method I added a moment ago. Once that promise produces the access token, I can construct an HTTP headers object and call the set method to set the authorization header to a value of bearer, space, and the token value. Now I need to move the HTTP call inside this promise handler and add the headers to the call. But I still want to return an observable of project array so that the consuming code does not have to change. To do that, I can use the toPromise method to convert the observable from the HTTP call into a promise. Then I can return that from the promise handler of the getAccessToken call, and then use the from operator of RxJS to convert that back into an observable that I can return. With that code in place, I can save, go back to the app, go to the My Projects page, and behold, we are now getting our projects again. So at this point, we could go to each of the individual service methods where an HTTP call to our APIs is being made and add the access token to the headers manually like I just showed. The problem with that is it would obviously add a bunch of duplicate code that's hard to maintain. One of the reasons the Angular team deprecated the original HTTP service from Angular 2 and replaced it with the HTTP client service in Angular 4.3 and later is because the original service did not support an interception model. When making HTTP calls from a client, you often need to have some custom code that gets invoked right before a request goes out or right after a response comes back in, regardless of where those calls are being made in the application code. In our case, at this point, what we want to do is add the access token to the authorization header right before any call is made to our APIs. The HTTP client service enabled this using what is called an HTTP interceptor. So let's create an interceptor that will add our access token to the requests automatically for us. I'll add a class to the core module here named auth-interceptor.service.ts. In there, I'll again use a code snippet to stub out the boilerplate code that is needed to create an interceptor class that sets headers on the requests. So I'll type a dash to get a list of snippets from John Papa's Angular snippets extension, and then select the one that is for an HTTP interceptor with headers. I'll name the class auth-interceptor-service, and I'll set the provided-in property on the injectable decorator to core module. In here, we will basically be doing the same thing I showed a moment ago to manually add the header, but by doing it here, it will be done automatically for all requests. So first, I'll inject a reference to the auth service in my constructor. Then, in the intercept method, I'll get the access token as I did before and create the headers as I did in the project service. Clone method. I will return the result as a promise since it's wrapped in a promise again, and then convert what comes out of that into an observable. Notice the structure of this interceptor. It is part of a handler pipeline architecture used by the HTTP client. So when your intercept method gets invoked by the HTTP client when a request is being made, the request is passed in as an HTTP request object that you can inspect and or modify before it actually goes out on the wire. You also get passed this HTTP handler parameter named next, which represents the next piece of middleware in the pipeline. The expectation is that you will do what you need to do, then invoke the next handler, unless what your interceptor is designed to do is block the request from going out based on some criteria. You can also use an interceptor to look at the response that comes back after invoking the next handler. I'll get into that later for detecting 401 and 403 status codes and using those to drive renewing your access token or sending the user to a login page and showing an error. While I'm here, you should consider whether it's appropriate to blindly add the access token to any requests going out from your app. I probably can't anticipate how this app is going to evolve over time, and it's certainly possible or likely that there may be calls going out to other APIs besides my own. So I probably don't want to blindly add my access token to all calls that go out, only those that I know are going to my own APIs. So I'll add a check here to see if the request is going to one of my APIs by using the URL that is in my constants and only add the access token if they are. Once your interceptor is defined, you need to hook it up to the Angular HTTP client infrastructure. The way you do that is to go into the ng module where your interceptor is defined and go to the provider section of the module. In there, add a provider object that sets the provide property to the HTTP_interceptors object from Angular, set the use class property to your interceptor class, and the multi-property to true so that you could hook up other interceptors elsewhere in your app. If I save those changes and go back to the app, if I look in the debugger, I can see there's an error being thrown due to issues with dependency injection of providers. The issue here is that my other service components in the core module are using the provided in property on the injectable decorators to get them added to the module. But now I need to explicitly configure a provider in the module class, and that results in problems because some providers are being added one way while the interceptor is being added another. So the quickest way to resolve this is to go remove the provided in property from each of the service components injectable decorator, then go add those modules explicitly to the module providers. Now that they all get loaded in the same way, that resolves the injection issue. With that code in place, let me go back to the app and go to the details for one of the projects in my projects listing. That calls a different method in the project service that does not have the authorization headers hooked up manually. And yet, you can see the call is succeeding. If I look in Fiddler, you can see that is because the interceptor is adding the bearer token header that we need automatically. So those calls are being allowed through at the API. If I look at the logs at the API and the STS, there's one new issue introduced. It is a CORS warning that tells you you cannot leave CORS wide open with a wildcard domain when also allowing credentials through. To fix that, I need to go add my client domain as a specific domain that is allowed through with credentials. And I'll do that in the STS as well. And now, if I go refresh the app, you can see those warnings are gone now. Next up, let's look at filtering data based on the caller identity. Now that the calls are being authenticated in the API, there is a security context that will be available to your code in the back end to make decisions about what the caller can access. The way this manifests itself is going to be very dependent on what technology or framework you're using for your back end. In .NET apps, whether full framework or .NET Core, what happens is that a security principle is established based on the contents of the access token. This principle is called a claims principle and will contain all of the claims that came in through the access token after it is validated. To get to it, you can use the user object on your controller base class, or you can use a static reference to claimsprinciple.current. So one scenario you can use this in is to filter data returned by the backend based on who the caller is. To see what we have available to us, let me just dump all the claims and their values out to the console window when a call comes into the getProjects method. I'll go back into the client app, load the projects view again, and then go look at the console that's running the API site. There, you can see a bunch of claims dumped out, most of which we've already talked about. Note that some of the claims have URLs for identifiers instead of the short token names we saw when looking at the tokens in the jot.io site. This is because the Microsoft Authentication middleware sets up some default mappings to URIs for the claims that have named URIs associated with them. That's not necessarily a great thing, because as you can tell by the years in some of these URLs, those